Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome back to our lecture Power Systems BAJ 20603. Okay, chapter Balance Three-Phase System. Okay, today we will discuss last subtopic for this chapter, which is 3.5 three-phase load connection. So we will discuss about three-phase balance analysis. Okay, balance three-phase analysis for Y connected load and delta connected load. Okay, so previously we already discussed about Y connected load. Okay, so today we try to summarize what we have done last week. Okay. So what we have done last week, we try to summarize. Okay. Last week we already discussed about balance YY system. Okay, we already discussed about Y connected load. Okay, we already discussed about balance Y connected load. So we can conclude that relationship between line voltage and the phase voltage of the Y connected load basically is equal to the relationship between line and phase voltage at the Y connected source. Okay. Basically, let's say we have phase voltages at the load at the generator side or at the source. Okay, let's say we have a VAN as a reference, so we can determine VBN and VCN according to the ABC sequence or positive sequence. So the different angle between each phase actually is 120 degree. Okay, let's say we have phase voltages, so we can determine the line voltages of the source. Okay, line voltages. What is the relationship between line voltage and the phase voltage for the Y connected system? Basically, the concept actually is exactly same for the Y source and then for the Y load, which mean that line voltage basically equal to square root 3 V phase angle 30 degree. Okay, angle 30 degree. Okay, similarly to VBC, okay, we can determine VBC equal to VAB just minus with 120 degree, and VCA equal to VAB. Okay, so the angle you just plus 120 degree. Okay, so how about the phase current? So phase current at the Y system, Y connected, basically equal to line current. Okay, so the question is how to determine line current. Okay, so in order to solve the three-phase balanced three-phase system, we can use the per phase equivalent circuit. Okay, do you still remember the per phase equivalent circuit? Okay, what is the per phase equivalent circuit? Okay, in order to determine current IA, IB, and IC, so you can analyze based on per phase equivalent circuit. So in this case, you analyze according to the phase A. So from this phase, you can determine IA. IA equal to VAN divided by ZY. Okay, VAN divided by ZY. And then you got IA, so you can determine IB and IC. Okay, so the magnitude is same equal to IA. Okay, but the difference actually is phase angle. Okay, minus 120 degree. For the IC, the phase angle you need to plus 120 degree. Okay, okay, that's the summary of the balanced YY system that we have discussed in the previous lecture. Okay, so today we will discuss about delta load. Okay, delta load. So what we need to do actually is we try to determine the relationship between phase current and line current at the delta load. Okay, this is the delta load connection. Okay, this is the delta load connection. Okay, so similar with the Y connected load, the notation that we use actually is capital letter. Okay, for example, phase R we use a capital R, capital Y and capital B, IR, IY and IB. So this is a line current. Okay, this is the IRY, we call it a phase current from R to Y. Okay, from Y to B, IYB, and then from B to R. This one we call it a phase current. Okay, so in this slide we try to analyze the relationship between line current for the load and phase current for the load. What is the relationship between phase current, between line current and then phase current for delta connected load? Okay, so based on Kirchhoff current law, you can determine IR. Okay, IR equal to IRY minus IBR. Okay, based on KCL. Okay, similarly to IY at this point. Okay, at this point you can determine IY. IY equal to IYB minus IRY. Okay, then you can determine IB. What is IB? IB equal to IBR minus IYB. Okay, this is a line current. Okay, this is the line current. So, okay, we assume our phase current as a reference. IR equal to I angle 0, IYB equal to I angle 100 minus 120 degrees ampere, and IBR equal to I angle 120 degree ampere. Okay, this is our phase current. Phase current IRY as a reference. So the question is, what is the relationship between line current and phase current? Okay, so you can determine IR, okay, by calculating by using this equation, IRY minus IBR. So by using that equation, so you can so you obtain this relationship. So IR equal to square root 3 I phase angle negative 30 degree. So we can see that line current, the magnitude of the line current equal to square root 3 I phase, but the angle equal to negative degree. Okay, you can see that this is a reference for your phase current. This is your reference for the phase current IR. Okay, then this one is the line current. So from this phasor diagram we can conclude that line current lags phase current by 30 degree. Okay, for delta connected load, line current lags phase current by 30 degree, and the magnitude is times by square root 3. Okay, so IY equal to, okay, we have a same magnitude IY as IR. So the difference actually is angle, just minus 120 minus 30 minus 120, you will get minus 150, and then this is your phasor diagram. Okay, and then IB equal to, we have a same magnitude, but different angle by minus 240 degrees. Okay, so minus 30 minus 240 degrees, you will get 270 degrees, or equal to positive 90 degrees. This is your IB. So what we can say from here, so we can conclude that line current lags phase voltage by 30 degree, and then the magnitude of the line current actually is square root times of the magnitude of the phase current. So we can see that the relationship of the line current and the phase current for the delta connected load basically is equal to relationship of the line currents and phase current at the delta connected source. Okay. Okay, so let's try this example. Okay, let's say you have a 400 volt 3-phase supply is connected across a balanced load of 3 impedances, each consisting of a 32 ohms resistance and a 24 ohms inductive reactance. Okay, determine the current drawn from the mains. Okay, what is the meaning of the current drawn from the mains? Okay, current from the supply if the 3 impedances are connected in delta connected. So you can use VRY as a reference, and then RYB as a phase sequence. Okay, use a RYB as a phase sequence. Okay, can you calculate IR, IY, and IB for this question? Okay, so first you can try by your own how to determine IR, IY, and IB, and then in the next video we can discuss. I will explain in details to you how to solve this example. First you can try how to calculate IR, IY, and IB according to the concept or relationship that we already discussed in this slide. Okay, so that's all for this subtopic, which is delta connected load. Okay, delta connected loads. Okay, so that's all for this subtopic.